Welcome to NDJWonders, a channel under NDJProductions. Today, we're exploring a breakthrough that blurs the line between thought and reality. It begins with a device no larger than a shirt button, a strange array of metallic spikes, and a discovery that first surfaced in the late 1990s, inside a quiet lab at the University of Utah. It's called the Utah Array, and it has changed how we understand the human brain. But the deeper researchers dig, the stranger this technology becomes, because it reveals something unexpected hiding in the electrical noise of our minds. The Utah Array was built for a simple purpose. It was designed to listen. Each tiny spike is an electrode, placed gently into the surface of the brain to record individual neurons firing. At first, scientists wanted only to map movement signals. They hoped that one day, people who lost the ability to move could control robotic limbs. And this happened. Paralyzed patients were able to move robotic arms, grasp objects, and even type using pure thought. At first, the recordings looked clean. Signals rose and fell in neat patterns. Movement commands appeared like small waves on a digital ocean. But there was more. Researchers started noticing faint echo-like patterns hidden deep in the recordings. Signals that didn't match movement, sensation, or even known cognitive processes. For a long time, these echoes were dismissed as noise-static interference, but then something unusual happened. As experiments continued, these faint signals remained consistent across different subjects, different brains, different ages, different backgrounds. And yet the echoes repeated in nearly the same frequency ranges. The discovery unsettled people. Neurons fire based on experience, stimulus, and intention. But these quiet waves were predictable and rhythmic. They looked less like random noise and more like an internal system the brain never meant to reveal. To understand why this mattered, we need to step backward for a moment. Neuroscience has long known about brain rhythms: alpha waves for relaxation, beta waves for focus, theta waves during deep meditation. But the Utah Array sees something deeper. It listens to the individual spikes beneath the waves, the microscopic electrical pops of single neurons. And this is where the mystery deepened. Beneath normal firing patterns, researchers began noticing bursts that seemed to activate before a subject made a decision. Not after, not during, but before. It was as if the brain was whispering its intentions ahead of time. This isn't entirely new. In the 1980s, neuroscientist Benjamin Libet discovered a strange phenomena called the readiness potential. Using simple EEG equipment, he found that the brain prepares for a movement before a person becomes consciously aware of choosing it. The Utah Array offered even higher resolution, and what it uncovered mirrored Libet's findings, but in sharper detail. Instead of seeing broad waves of preparation, the array captured exact neurons, firing milliseconds before a subject said they intended to act. However, the real surprise came next. These predictive firings didn't just apply to movement. They appeared during visual recognition, memory recall, and even emotional reactions. Tiny electrical patterns flickered in the brain seconds before the conscious mind seemed to catch up. It was as if the brain knew what it was going to think before the thinker thought it. Over time, scientists grew more curious. What if the echoes weren't noise at all? What if they were the earliest signals of subconscious processing? To explore this, researchers designed an experiment involving rapid image flashes. Subjects were shown pictures so quickly that many never consciously registered them. But the Utah Array recorded the brain's response anyway. The echoes strengthened, forming patterns that predicted how subjects would react once the images slowed down. Even when participants said they didn't see anything, their brain activity hinted otherwise. But there's more. In a later study, participants listened to distorted sounds that humans usually cannot identify. Surprisingly, the Utah Array showed activity matching recognition patterns, even when subjects insisted they heard only static. It suggested the brain may interpret and categorize information before awareness takes hold, like a silent observer analyzing the world behind the curtain of consciousness. What happens afterward is even stranger. In some cases, the array recorded predictive patterns that didn't align with the subject's final decisions. The brain prepared one outcome, But the conscious mind chose another. It revealed a conflict between subconscious impulses and conscious choice. This raised an unsettling question about free will. If part of the brain begins preparing a decision before we know it, how much of our life is guided by awareness, and how much by hidden processes? Yet the story doesn't drift into philosophy alone. There's a practical side to this mystery. These predictive signals could be used to give paralyzed patients faster and more fluid control of prosthetic limbs. Devices could respond to intention even before the person becomes conscious of the movement. This could shorten reaction times and make brain-controlled tools feel more natural. But the same principle could allow a machine to read the direction of thought before thought fully forms. The science is real. The technology exists, and the ethical questions grow louder every year. To understand this better, neuroscientists expanded their research into sleep studies. During deep sleep, the predictive echoes didn't disappear. Instead, they synchronized into slow, sweeping waves. These waves resembled the patterns seen before memory recall in waking subjects. This supported a theory long suspected but never proven in such detail, that the brain replays and reorganizes memories at night, long before we wake and remember them. But the Utah array showed something deeper. The echoes didn't just replay past experiences. In some cases, they formed patterns scientists had never seen before, suggesting the brain was creating new associations, new links, and new predictions. What's more intriguing is that these predictive patterns sometimes appeared before dreams began. They acted like a spark, setting the stage for the images and stories that followed. Dreams have always been mysterious, but if the brain prepares them ahead of time, then dreaming may be less random than we thought. Instead of the mind wandering freely, it may be following hidden paths laid down by the subconscious, guided by these faint electrical signatures. Meanwhile, in labs across the world, from Stanford to Brown University, scientists working with brain-computer interfaces kept reporting similar anomalies. No matter the subject, no matter the experiment, the hidden echoes appeared. They weren't identical. They weren't universal, but they followed enough common structure to raise eyebrows. Some researchers described them as the low-level language of the brain, a quiet code operating beneath awareness. Others believed they were simply the earliest steps of thought, usually invisible, without invasive sensors. However, one group studying epilepsy patients stumbled onto something even more unusual. When electrodes were placed deeper in the brain, near the hippocampus, the predictive signals appeared to trigger before subjects recalled specific memories. But sometimes the signals fired even when subjects retrieved memories incorrectly. It meant the brain sometimes predicted the intention of recall without verifying the accuracy of the memory. This added a new twist. The brain seems to prepare to remember before it ensures the memory is true. That could explain why confident recollections are sometimes wrong. The story of the Utah array and the surrounding research continues today. The more scientists listen, the more they uncover patterns hiding inside the electrical storms of the mind. Each discovery reveals a brain far more active, predictive, and mysterious than we ever imagined. Instead of a simple engine of thought, it appears to be a layered system, where subconscious currents shape decisions long before consciousness arrives. These echoes aren't supernatural. They aren't mystical. They're electrical traces left by billions of neurons coordinating in silence. Still, the implications ripple outward. If technology continues advancing, machines may soon interpret these predictive waves with astonishing precision. They may detect fears before we feel them, decisions before we make them, and memories before we recall them. And somewhere in the middle of this frontier lies a question that science has not yet answered. Are these echoes simply the earliest sparks of thought, or are they something the brain has always kept hidden, something we're only now learning to hear? If you enjoyed this video, visit the links below for more content from NDJ Productions and NDJWonders.